Okay, so we're going to do lesson 2.4. This is going to be rotations. And let's see, we're going to learn a little bit about the notation and how to rotate them clockwise, counterclockwise, and so forth. So let's see what that looks like. All right, so rotation is a turn. It's going to rotate at about a point. It's called the center of rotation. A lot of what we're going to be doing is using the origin as the center of rotation. And if we use the origin, we will have some special notation that we'll be able to use. And I'll get to that in just a minute. In a rotation, the original figure and its image are congruent. So that's important to understand. When we talk about the angle of rotation, we're talking about like each point in relation to that center of rotation. So let's say we're dealing with this point right here. Oh, that's not what I wanted to do. Let me get to a pen here. Oh, we get to do a lot more colors. So we're doing this point right here, and that point, and this point, say, would form, and it's a 90 degree, and this turn is clockwise. So this is an example of a 90 degrees clockwise rotation, 90 degrees clockwise rotation. And so that's how we're going to be describing them. It has to be a degree, like a measure of the angle, and also a direction. Okay. All right. So identifying the rotation, you must rotate this puzzle piece 270 degrees about point P to fit into the puzzle. Which piece fits in the puzzle? So here is the center of rotation. Now, look at this picture right here. Notice that 270 degrees clockwise, right here, clockwise, is also 90 degrees counterclockwise. Oh, I can't even spell. Let's just try this again. Okay, so 90 degrees counterclockwise is 270 degrees clockwise. So that's one way that we can use it. I mean, we could do, 1, 2, and then 3 separate moves, or we can do one move in the opposite direction and take this piece in that direction to get the same effect as this one. So keep that in mind because that may be very helpful for you. Okay. So we can see that the correct answer is C, because this piece right here matches. Okay. Great. Now, which piece is 90 degrees counterclockwise in the rotation? So if I go back, we just got done saying this. I just got done. Hold on a second. Oops. I haven't recorded a video in a while, and you can see I'm a little rusty in the tools. So here we go. This piece right here, same one. C. All right. So the correct answer is C. Okay. Is choice D a rotation of the original piece. So here's the original piece, and here is choice D. What do you think? Is this a rotation? If not, what kind of transformation do you think that it is? Okay, well, if you can kind of see, it looks like it's a reflection. So no, it is not, and it is a reflection. Okay. All right. Looking at an example from your book, here's the vertices of a trapezoid. Here's our original. We're going to draw the original. That's something you're going to be asked to do. And then you're going to rotate it 180 degrees about the origin. What are the coordinates of the image? So one thing we haven't been asked to do so far is, work with those, the notations, and I'm going to be giving you those shortly. So I'll give you the notations that you can write down in your notes with the next example. Okay. But what we need to do is, so for each point, it has to form. So from this point would have to go, here and then straight here. This, Y has to form a straight line, straight down in here. And so you can totally eye it up like this. I think this is much more difficult than actually calculating it. You know me and wanting to calculate things. But you would have to line it up like that. So here are the coordinates of the image. Notice, look how they vary. We have 4, -2, 3, -4, 1, -4, and 1, -2. And so for a 180-degree rotation, so 180-degree rotation about the origin. Okay, so the notation would be, we would have our original x comma y, and that would go to -x, -y. So you might remember these from the reflections where only one of them was multiplied by a negative. In a 180-degree rotation, they are both multiplied by a negative. So we went from -4 to +4. We go from +2 to -2. Okay? So the 180-degree rotations are pretty easy because they stay in their same place and they just get multiplied by a negative. All right. So now let's take a look at the counterclockwise. So if we're going to do a counterclockwise, I'm going to abbreviate it like that. Counterclockwise is going to take your x comma y, and it's going to take it, now this is what's going to get crazy. It's going to reverse the numbers. You're going to have okay, so the notation here is going to be, for counterclockwise, the x and y change place only in number only. So we really don't do the x coordinate first or the y coordinate first, but here how you have a 4, 5, it will change to a 5, 4. Okay, so they reverse the positioning of the number. Okay, that's all that's happening here for when it comes to graphing it. And then for the counterclockwise, and this is also the opposite of the y coordinate, so it would be a -5, and then you have your x coordinate. Okay, so if we're going to rotate this, we start out with our original ones. We have our, for Q, 4, 5, and we have R, 4, 0. And so I like to list the coordinates first. Okay, now I'm going to reverse them. I'm going to put the 5 first, and I'm going to make it opposite. So it's going to go, and it's going to be my new x. This is my new x coordinate. and then the 4 does not get multiplied by -1. So this is just to show you that the numbers switch places, okay? So we can't have -0, so it just stays as 0. All right. All right. And so that's Q prime. That's R prime. So it's important to use these prime notations. So I'm going to go ahead and graph this then. I've already graphed the original. So starting at 0, go back to -5 and up 4. Right here. And then mark it Q prime. Here, 0, 4. And that's R prime. And here, 0, 1. And that's S prime. And so the purple one is my rotated. Now, it is rotated 90 degrees counterclockwise. And if you look at each point, like S forms a 90-degree angle, R forms a 90-degree angle, and then Q actually does form a 90-degree angle, okay? What we want to know is, are these two triangles congruent? And the answer is yes, they are congruent. So notice that we turned them, but we have not changed the shape at all. Also, on your note packet, just ignore the actual question B, where it says to rotate the triangle 180 degrees about vertex X. S. We're only going to be rotating about the origin, so you can just cross that one out. Okay. So when we're using more than one transformation, this is the original. Here's the vertices. We're going to rotate it 90 degrees clockwise, so it's going to get rotated to the blue. Then it's going to be reflected. And so that's something that, you can show the final. And notice that they use 1 prime and then 2 prime for the final right here, the 2 prime notation. Describing a sequence of transformations. So, one thing you can look at is here you have the red one. You can turn the red figure 90 degrees so it's in the same orientation as the blue. And you can see that right here kind of highlighted. And then you can translate it up. So that's one possible sequence of transformations is a 90 degrees counterclockwise. It's going from here to here, 90 degrees counterclockwise, about the origin, followed by a translation 4 units up. And how you know that you've gone 4 units up is from one point you count 1, 2, 3, 4. All right, the last one we're going to do, we're just going to come up with the coordinates of 270 degrees counterclockwise. And if we're going 270 degrees counterclockwise, this is the same as 90 degrees clockwise. So this is also the same as 90 degrees clockwise about the origin. And the notation would be like this. So we're going to reverse the two x and y coordinates, and then we're going to take the opposite of the new y. So to get w prime, we would write -2, and then the opposite of the new y would be +6. X prime, we would have -2 and a +2. Y prime will give us -2 6 for our new x-coordinate, and a positive 2 for our y-coordinate, and z prime will give us -6 and a positive 5. So you would just have to list the coordinates. So what's happened is the numbers have basically essentially traded places, right? They reversed positions. And then the new y-coordinate is multiplied by -1. So since it was negative when it was an x-coordinate, in its y-coordinate position, it's a positive because it's multiplied by -1. So it's just a lot of keeping track. Okay, so that's why it's always kind of nice to have this template to go by in copying these down. And so a lot of times you'll just be asked to list these. So I'll be giving you a handout in class that'll summarize all of the notations so that you can, keep those handy and in front of you to go by. Okay? So if you have any questions at all, please ask them. All right. That should be it.